So we didn't have a meeting the last 2 weeks, so we're catching up here, I guess. My points are Terry sent me a message. He's trying to build his. He's still working on his autonomous snowblower, and he just told me his current point. He's trying to measure his battery voltage. He's got two drill batteries on there, and he wants to put a voltage divider on each one and read that with his little microcontroller. So that's where he's at on his stuff. And then also when I was out digging through my garage, uh, in the past, I built that mini tractor, which I could say it's this one right here, but I got the wrong background. Here, let's do this. Change background. Wow. I can say it's this one. When I built this one, it's got a transaxle out of a like a mobility scooter in the back. So it's just a this nice aluminum gearbox that you just bolt down to the frame, and it's got an electric motor on it. The same kind of motor they put on a wheelchair, and that worked out really well on that. And I'd totally forgotten that years ago, when I was doing BattleBot stuff, helping out with the BattleBots guys, I bought three transaxles like that from that guy. I think I only paid like $5 a piece for them, and I threw them out in my garage. And I'd totally forgotten they were out there. And then one day I thought, hey, those are out there. So when I was digging through the garage, I kept looking around, working my way around, looking at all the boxes, and I thought, well, I don't know what happened to them. They have to be here. And I just had one little corner left, and there's no boxes in that corner. I was out there a week or two ago digging through, and there they were, just laying on the floor in the back in that corner. So they were where I thought they should be, and I pulled them out, and the brand name on those is Pride, and Pride is a brand that makes wheelchairs and mobility scooters and stuff. And they look like they're physically, they might be bigger than the one that's on this one, and the motor might be a bigger motor on it, so that might be um, good if I decide I don't have enough power. This one, the one I've got on this one right here, seems to work really well. It's the speed of it. It seems to be an adequate speed. The problem is I can't drive it up a ramp into my car, and partly because I'm running it on 12 volts instead of 24 volts. And then also, I don't know if I had enough voltage, it might burn up my motor drivers. So I haven't really pursued that. But I was thinking that I've got these other ones. If I decide to build something else, I've got stuff to put on there. And the only other major difference, the fact that they're slightly larger, the width is probably the same, because I'm guessing they'll make them all the same width for just for getting through doors and everything. But it's got the mounting. The one I've got right now has like pillow block bearings on both axles. So you just drill holes in the frame and put bolts through and bolt it down. And the other ones I found have some kind of like a square, it's like a square rubber insert or something on the shaft. And so you have to make something on the frame to hold that. And I've given enough thought. Probably I can come up with something to make that work. But so one of these days I'll have to pull those out and try them out and make sure they work, and then decide, do I want to build yet another robot that I'm not going to do anything with or not. So that that's just something that came up that I now have some of those, and they are in hand. So I just need to go down the path on that. So I think that was the two things I wanted to mention. That Terry is working on his stuff, and that's where he's at. He's trying to get his measure his battery voltage, so he knows how much battery life he's got left, I guess is the way to state that. And then I found the transaxles, and uh, that's all I can think of right now. So I'll turn it over to Al.
There we go. Get off mute. Um, so a little bit of progress that I made is around documentation and at the same time building a path. So I posted out here to Slack a PDF that's got some documentation that I updated. Basically, so I've got a functioning robot. I can capture RTK and it can accept commands. So now I need to build the path for it to follow. Um, and to build that path, I'm sure you could think of a dozen different approaches, but here's at least three different ways to do this. I'm going to say historically, we've taken a few points, put them into something that I call the Dubin's path generator, and it would generate the U-turns and additional points for the robot to follow, and that all works perfectly fine. Another approach would be to drive the entire path and think of, cutting a yard of grass. Um, you're going back and forth, and visually keeping track of the segments and avoiding obstacles, and you save all that in a ROS bag, and then you just generate a path to repeat exactly. And that would be fine too, except for me, I cannibalized my tractor, and so you can't sit on it anymore and steer it in manual mode. It is, remote control only, and steering that with remote control is a little bit, it's just call it less precise. So the process that I've taken is to drive via remote control at least the outside perimeter, capture that data, and use that data along with the obstacle information, and calculate, a precise path following precise angles. Um, in retrospect, uh, driving the path might be the easier, simpler approach, but anyway, I'll show you what I've got so far. So I've put it in a PDF, but in actual fact, the source document is a Jupyter Notebook. I've had the information spread across a couple of different documents and platforms. So what I've been taking time to do is just to get it all into this one Jupyter Notebook. You could just store it in a Word document just as easily. But I chose this platform because I can also run some code in it when I want to, which has got some pluses and minuses. But anyway, that's where it is. So I'm not going to go through each step, but to suffice it to say that there's a bit of a manual process where you take the ROS bag data, you pull up you pull up Plot Juggler, and you're attributing the data that you've captured in a CSV file with which of these segments represents the way that you want the robot to go, and which of these segments represents an obstacle. So, for example, this circle represents an obstacle. And again, for me, I calculate the center of that obstacle and then draw, what I refer to as the best fit circle around that obstacle. I add some buffer or inflation to that to say, okay, robot, I want you to use the green line as the steering path around that obstacle when you do encounter that. My nomenclature in this Jupyter Notebook is when I have a program that I want to run outside of Jupyter, I put it in this sort of format so you can copy that whole command and paste it in. Again, all of this stuff is up on GitHub, so if you downloaded the whole thing, you would get all of this code, in the same folder sequence that I've got. So after I've got some information about the obstacle, I use the one outer path that I drove and create the subsequent outer rings. The reason there's this seeming gap here is because this is where I was driving around the obstacle and basically excluded some points because of the way the data was looking and captured. This is just a close-up of where I'm starting the rings. So the first point of the path would be here. The ending point of the first ring would be here. The tractor would then go from here to here, run this ring, come back around, end here, and then go to the third ring and end here, and then go here. And this would be the final ring, and it would end here. That's important because I'm going to show you one of the dilemmas I have at the moment. There's some math to see where these rings intersect with the obstacle, and then there's some further math to say which is the shortest path around this obstacle. So you can see for the first ring, it goes this way. For the subsequent rings, it goes, what would that be, in the clockwise fashion around that obstacle. Then it takes that, puts it all together and says, hey, this is for the outer rings. This is the path that you're going to run. And so now I've got this outer path, but I don't actually have a fully executable mission yet as far as the robot goes, because the robot is also looking for theta, or an angle, the speed you want to go, and the look ahead that you want to go. So I've got to add that data. And, I could have one big monolithic program to do all of this, but when I went back and was cleaning up the documentation, the bigger monolithic program that I had, the harder it was for me to remember exactly what I was doing and why. So that's why I call this sort of a semi-automatic process, where you just step through these individual steps. Basically, the most you've got to do in these steps is confirm which file you want to interact with. And I only have one Excel sheet that I'm using, and I create subsequent sheets. So everything is in that one um, one file. I think actually, do I have it open? I do. So I'll just digress a second and say, so the site survey data is, the actual latitude and longitude, and the pose data. This reference is, me attributing the points that I'm going to save. I also attribute which is the very first point, and so on. So everything is in this spreadsheet that, I'm using, which was, for me, a cleanup process because I had multiple files sort of spitting around everywhere. So then I take this polygon, which is the innermost ring, and I feed that into a process that creates what I call stripes. And lo and behold, what I get is something that looks like this. These stripes have a couple of points that are really small or disconnected, so I trim those off. Just double check that everything looks the way I want it to look. So these are those stripes, and then I create a series of right angles on each of those stripes in order to be able to feed the Dubin's shortest path process endpoints. So what that will then ultimately look like is this continuous path. And there's these 2 points at the end of each of these, and that helps to calculate the Dubin's path. I've got to reformat that because it's in multiple pieces of data is on one row, and I need to, again, back to the path, the Dubin's process, and the way to feed the pure pursuit algorithm is you need to have one row for each point. So I clean that up a little bit. And I finally get down to what Jeff will remember as some code that we got from Matt that creates the shortest path in the Dubin's U-turns. So there's a lot of legwork to get to that list of points, because Jeff and others who know how to create those points sort of visually or manually, they'll remember this is where the actual Dubin's U-turns are made. And so that's what this looks like. And you could potentially visualize that these stripes would fit into the boustropen, or I'm sorry, the outer rings. But the point I want to make is that this happens to be the beginning, which is a little bit funky, and that's where I'm at the moment. Is this is a detail of that beginning series of points to run the stripe, and I've got to marry that up with the path. And so what I have at the moment is two issues with this. One is the cleaning up the points so that this is a better, this upper right corner, which is a little bit hard to see, but I've got a more detailed picture of that here, I think. So this is a bit of a mess getting from where I end. This is the point where I end the 4 inner rings, and I've got to get over here to start that. So thinking through how I want to do that, or just leaving it be and seeing if it figures itself out, or I could run it in simulation and see what it does. But anyway, that's one issue. The other issue you probably noticed is, come on, Mr. Firefox, get back to, oh man, can you still hear me, Jeff?
Yes, I can.
Yeah, I got something. Okay. The other thing is these line segments around the obstacle. Oh, Jupyter's complaining. Why is Jupyter reloading? What did I do? I'll go there. These line segments around the obstacle are too long, so I got to shorten these so that this U-turn doesn't try to overrun where the obstacle is. So that's the other thing I've got to clean up. So fixing that transition and fixing the shortening those line segments enough to give it space to do the U-turn. That's where I'm at. Questions on any of that?
I had a couple as you're going through it, and I forgot what they were.
Oh, sorry, I should have paused. I'm going to stop sharing and see if I can clean up my screen there. Oh, I got a whole bunch of viewers going on. So that's it for me.
I guess I'm done too, so we'll stop for the moment.